Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Unleashing the LLM potential with memory. 7 types of memory to use with large language models in Langchain. What is the reason for making the large language model to remember? Memory provides the concept of state in an interaction or a conversation. When you are continuously having a discussion, so we have been always seeing this happen, that you want to suddenly remember something that you spoke before 5 minutes. The same way, when you are interacting with large language models, you might want to use data that you provided to the large language models in the past to make a decision in the present moment. So that is called as concept of state. We can extract multiple pieces of info from the sequence of memory and chat memory that is going on. We can control how much memory is getting stored. We can summarize the entire chat. All these things we can do. And also we can use this memory inside the agent as well as chain. The memory that I'm talking about here is string values. I'm talking about simple string values inside the Python that you can actually use it, or JavaScript for that matter. You can use it for taking additional decisions and also using it for changing the conversation route. All these things are possible. How to make it remember? That is the second question. So you might be wondering, what is the process or what is the methods we have to use? So in case of Langchain, there are 7 different classes that has been provided. All are linked with the memory, and you can find these classes under the memory module in the Langchain documentation. If you see this, see the overview of it, you will see that there are a couple of buffer memories. So inside the buffer memories, we have the regular memory, and we have window and token buffer memory. These 3 are grouped together. Okay, these are all buffer memories. And you see at the bottom there is actually summary memory. So this is actually summarizing memory classes, and in the middle these 2 are actually different. So these are unique. The entity memory provides the entities inside the memory that is working on. So if you have come across named entity recognition, so this entity memory is linked with that. And knowledge graph, you must have read about this, or you could have seen as ChatGPT was evolving. Knowledge graph was one of the main topic that was circulating a lot. So there is a way to extract the knowledge graph from the memory itself. So this is an overview that I'm providing it to you, and you can see the red font provides the hints related to each of these classes that is available inside the Langchain library. The point here is that this is very theoretical. Okay, only when you see this in action you will understand. Okay, so this is the capability of memory. So you may not be even knowing. So I have been also interacting with Langchain, and till recently I was also not very much involved in using memory, but it is one of the important concepts that we have to start understanding and start implementing. That is one of the major motivation for making this video. Before we dive into action and see what is going on, I want to give a little bit of a context around the various classes inside the Langchain memory module. Any class in Python will have methods, and these methods are the workhorses of that particular class instances or the class itself. In case of memory, there are we already saw the classes, and there are a couple of additional classes called as human message and AI message. And the main class is base memory and base model. You can see that here. I'm talking about these here. So these memory classes inherit from base memory and base model. Apart from this, the methods that are available with these classes are listed here. Okay, all these methods are not available with all these classes. Okay, what happens is I've listed all the methods here for an overview for you guys. Okay, so when you are trying to work with the classes, save context and load memory variable, these 2 are available with all of the classes, all of the above memory classes. To my knowledge, I have to still recheck it. And depending on the type of the classes, so the get current entities will be with the entity memory. Predict new summary will be with the summary memory. and chat memory and chat add user message and add AI message will be with chat message memory. So here that I have not included it here because that is not coming in conversation. We will be looking at it in the action also. The point I wanted to make here is that there are certain memories. So all the memories may not need an LLM. So we will see that in action in the next slide. So let me go to the next slide. So here I am telling, let us actually add the memory to the chain or agent. Both chains and agents require prompts, and prompts are the major driver of controlling the memory. So in fact, large language models are controlled by prompt and prompt engineering. The prompt engineering is automated by Langchain library. So this is the ecosystem connection between the three steps. So we have large language models. It solves a series of problems. For solving it, we give the prompt to the large language models. Langchain helps you to create the prompts in the very repetitive and understandable format. The point, the benefit the Langchain library provides you is that it actually breaks down the prompt into concepts. So for an example, it starts with prefix. So you see the concepts, right? It starts with prefix. We say that, okay, we are going to give you tools, and then we give you suffix. And by this, we are actually informing not only the large language models that this is the tools that will be given to you next. We ourselves will know how to actually access the tools. This is more important. At the end of the day, we can write prompts for pages together. We can engineer it as much as we want. But how are we going to make it repeatable, and how are we going to make it transferable? So tomorrow, if you are going to transfer the project to someone else, how are you going to do it? How are you going to explain it? So Langchain library helps us with all this prefix, suffix, chat history, input, various kinds of concepts they have created, and they have made our life way more easier than we can ever imagine. So without this particular kind of overview, it would have been extremely difficult to actually automate large language models. So that is something that I want to reiterate here. Coming back to the point at hand. So here what we are doing is we are creating the agent here. So you see this particular column on the left side of this presentation is about agent. So we start by creating the zero shot agent as a prompt. So zero shot agent is again a prompt. We use all the necessary prefixes and suffixes, and we use the chat history inside the prompt. But when we are going to get the chat history from, we are going to get it from conversation buffer memory. So this memory, this class is coming from this list. Got it? Conversation buffer memory. So this is what I was telling. So when you create this memory and you can actually put it inside. So you might be thinking, okay, Kamal, inside the zero shot agent, I am not having this particular memory. Where it is? What happens is you create the agent and then you create a separate chain and you pull in the chain inside the agent, and then in the executor, you start using the memory. You don't use the memory inside the prompt here. In case of agent, you don't use it. So in case of agent executor, it is a bit of a lengthy process, but you can have a lot of control. If you have understood my earlier videos where I discuss about agents, so yeah, you might be new to this particular concept also. So I am actually diving directly into this. In case if you are new and if you are totally lost in what is happening here, I would suggest that take a look at this particular playlist. I have discussed all of the concepts. I am going step by step in the concepts of Langchain. I have discussed most of these concepts, including agents, chains, large language model, automation, prompt engineering, all those stuff. So take a look at this video, you will get a fair idea. Going back to the PDF. So as I was explaining, we are creating agent in this left column, and in the right column we are creating a chain. So in the chain, what we are doing is we are again using the same conversation buffer memory, and we are using the buffer memory directly in the chain. You see the memory equal to conversation buffer memory, we are using it directly here. But in this case, here we are not using it. So in case of the LLM chain, right, we are not using here. So this is just the prompt that is coming from the zero shot agent. This is the difference in implementation. Both have different benefits. I'm not saying that one is good, one is bad. Each implementing using agent and implementing using chain are two different concepts altogether. So if you are thinking, okay, if you are working on chains and if you need to suddenly look off memory, then you can use this method. And in case if you are working more with agents, you are already exhausted all the other options, then you can look at the agents method. So enough theory. I would, I will share this particular GitHub repo link, which you can use it in Google Colab and start practicing this. The most important point, as I always insist in all my videos, that you guys have to practice. The more you practice, faster you will understand. And also the intention of, sharing all these methods will help you to directly dive into the notebook and start checking these methods and how's the output coming. So that will also show you that how to interact with the classes, Langchain classes, and in that process how to interact with the large language models also. So I hope that you guys have your OpenAI key ready for the next step. So let us head to the browser. First one, you can, this is the link, this is the repo this is the link of the Jupyter notebook. I'll be sharing this with you guys. You can take a look at that. And you can come to Google Colab environment. This is a very simple environment where you can use the upload notebook option and use the link that I share there, and you can start working on that. Okay, and just a moment. In case of this particular variable, you can enter your OpenAI API key here, and you can directly use it. Since I was using config parser library, it was a little more complex. So I have resorted to using directly the variable assignment. So I hope that you guys like this method. Next point is that the OpenAI API key is already ready, and we have the Langchain library and OpenAI library installed in this notebook. And also, whenever I am discussing these Colab notebooks, I really urge you that once you understand the Colab notebooks, move the code to a Python script and try running that inside your own environment. This actually matters a lot, because what happens is when you are trying to run it in your own environment, a lot of challenges will arise. In case of Colab notebook, the environment is fixed, but in your case, it's not. So there could be a different challenge that might arise, and share it with us. If you are able to solve it, also share it with us. The more we interact and more we collaborate, right, that will be much more helpful for the entire community. I hope that you guys will like it that way. Here, this chat message history. So this is something that I did not include in the memory because it is not considered as memory here. Okay, but still it is a history that we can maintain, and we can directly start adding the data to the chat message history instance. So you see that here. So we can use add user message and add AI message. And if I execute this, and you can actually see that we can get the data back. So if I open this and if I say history, if I type history here, and if I take a look at the various methods here, so you will start getting it in the Colab notebook, and you can see that we can actually work with the messages here. Okay, and if you try to understand, okay, what are the messages available, so then you will actually start understanding more about this kind of classes. So I do not have any kind of history maintained here. There is no any LLM here. There is no any kind of large language models involved. All I am using is simple Python construct, class construct, and I am using that for adding some string values inside the instance. So you guys can take a look at the class creation by looking at the view source here. I would really urge you guys to look at the view source most of the time. You will get a lot of information from this particular view source link. So take a look at that. It will be very useful. Now we are starting with the conversation buffer memory. What I am doing is, initially I am not initiating anything with the large language models. Again, as I did with chat message history, I am also adding the user memory. So you see that here, add user message and add AI message. The same thing I am doing with chat buffer memory also, conversation buffer memory. That is one way of adding data. Okay, so memory.chat_memory.add user memory. And then another way is using save.context. So both of these things will put the data inside the memory. So all these ways you have to understand, you have to explore, because you don't know when you will be needing these kinds of inputs. So sometimes you want to push some push some data into the memory. Then these kinds of interfaces are available for you guys. There is also a challenge, like when you are going to send the memory into action. So we will see that in a moment. So how to use these things in action, we have to also understand. So we have initiated the conversation buffer memory here, and I'm going to start a conversation chain. Inside the conversation chain, I'm going to use a conversation buffer memory. The rest of the things are same. I'm going to use a regular LLM, and this LLM I have already initiated. Just a minute. This LLM I have already initiated it here. Sorry, and I'm using it, and I'm using verbose equal to true, and I'm I'm initiating this particular conversation class. And remember, you see this here. I'm clearly telling, okay, this is my input. You know why? This is because if you click on this, and if you open the conversation object, and if you see, there will be a method to work with the prompt. Most of these classes, most of these instances that you create is actually prompts that are made. I explained to you, right, in the presentation, that Langchain helps you to automate the process of creating the prompts. And you see this input. This input is what you are pushing it here. So understanding this link is the key aspect of working with large language models and Langchain. Once you understand this key, then you know, okay, so whatever I'm giving in as input here, it goes into this input variable, and this input variable goes and sits here. And this input variable is given by the human. So you see the link. This link is what you have to grasp very strongly. Once you grasp this link, then you can easily manage any of the project challenge that you get from the get with large language models. So you see, I am simply asking, how are you? So the human is asking, how are you? Okay, the AI is replying, I am doing great, I am feeling very productive, and it is giving a lot of information. And this is the same thing that has been giving it to me, because I am using temperature equal to 0. Next, I am going to give another information. So I am going to tell, okay, I am the King Kong, so remember it. And yeah, it has to be funny also, guys. So when you say, okay, and it replies, hi King Kong, it's nice to meet you, I'm glad to know your name. So it clearly knows that I'm telling my name there. And then I'm asking, what did I tell you first? So now I am backtracking a bit, and I'm going back, and I'm telling, I'm asking what I told first, and it replies that you asked me how I was doing. So you see the interaction that is going on here, the back and forth activity, and it is also storing everything. So conversation buffer memory will store everything that you have. It will store everything that you interact with it. Now comes the fun part. If you are thinking, okay, how are you going to access this data? All you need to do is see the instance that you created here, the conversation, where it is. This is the instance that we created, correct? With the conversation buffer memory. You come down here, you click on, you use this conversation.memory.load memory variables, and if you execute this, you will directly get all the interaction that you are having till now as string value or dict value. So you can clearly interact with the memory even after it has been done. So think about it. When you are doing a product, or when you are working on a challenge, you are going to have a conversation. The conversation ends, or the conversation has to end here, because without the conversation ending, you cannot actually connect with the conversation memory.load memory variable. That is how the setup is, right? Without the conversation ending, you cannot touch this. So how to do that? So if you want to take a look at the memory as it is getting built also, there are processes for this. We will get to that in a couple of minutes. But after the conversation has been completed, you can access the history here. This is what I'm showing you. And this is simple Python, guys. There is nothing great about this. So next we are seeing the conversation entity memory. So conversation entity memory, unlike the conversation buffer memory, I'm not talking about the conversation. Just a minute. Let us go back to the presentation. see, I am jumping from conversation buffer memory to conversation entity memory. What about buffer window and token buffer? Both are similar to buffer memory, but it works on k past interaction and this works on last n tokens. So I would let you guys to experiment with this. It is, only thing is, it is filtering the number of interaction that is stored inside the memory. Okay, you guys can interact with this and you can understand the difference that I'm talking about. So I'm not going into that in deep. I'm jumping into conversation entity memory. So let us go back to the presentation. And in the conversation entity memory, you see that unlike conversation buffer memory, there is no LLM here. But in case of entity memory, you will have an LLM. Why you are having an LLM? Because this LLM is only going to find out what are the entities inside that. Conversation entity memory by itself cannot find out. This is not a Python only activity. So, but here it is Python only activity. In case of conversation buffer memory, sorry, I'm moving up and down. So in case of conversation buffer memory, it is simply Python activity. When I say Python class or Python activity, this can be done by using Python constructs. But in case of entity memory, you need the support of large language models. So that's why you see this LLM getting input here. And you see the same kind of prompts that is getting created, and you can interact with this. And you will see that initially, okay, so I am getting the error because I have not imported this conversation entity memory class here. And once I import this, you will see that I am getting the, I will start initiating the process, initiating the conversation entity memory, and I am giving the input by default. Before even I start working on working with the LLM, I am giving the input that, okay, Nona and Key are working on Clay House. So this is a silly sentence that I am making it, and I am giving it inside, and I am loading this memory variables. So this is a dictionary. I am loading it into the conversation entity memory, and then also you can do it like this. So after you load the input, you can actually say the output will be like this. So we can do that also. So load memory variables, and you can actually save the context also. And you can check it out, what has been done till now. The fun starts when you actually create a conversation chain and start using the conversation entity memory. So there is a module called prompt under memory class, memory module. You can take a look at that. That has an entity memory conversation template. So this template has to be involved whenever we are going to work with the conversation entity memory class. So keep this in mind. I'm going to, okay, this is going to again error out. So sorry guys. So I should have executed that first. And this will create the conversation. This conversation is different. So I'm maintaining all the conversation the same. And remember, we have already given the data here. So we have given about the Nona and Key. We have told about how it is to play with the clay, how you feel. And we are also asking the memory to give more inputs. We are doing all this stuff, and then we are starting the actual interaction. And I am asking here, Key and Nona are working with clay. So I'm just telling that again. I'm going to execute this, and you will see that the reply from the LLM. So here the difference is, you see the context, and you see how is the human and the AI are getting interacted here. You see the entire prompt. This prompt actually comes from this entity memory conversation template. So understanding the prompts with respect to memories are very, very important. We can see the memory store also. You can take a look at that. And here you see the entire prompt. So this is the prompt that it got created from this conversation class initiation. Think about it. All this has been already programmed inside the Langchain library, and it has been given to us. All you need to do is just initiate it and start using it. Think about writing all these things. It has been completely automated for us. When you are going to use it, when you don't understand these things, and when you are starting to get different results, you may not know what is going on. So understanding this additional information is very important. Okay, so what about, I have not gone through the knowledge graph. I have not gone through the summary memory and buffer memory. Why? Because The entity memory and knowledge graph memory are very similar. So you guys can experiment with that. And summary memory and summary buffer memory are summarization of these buffer memories and window buffer memory. So it is very similar to summarization agents. So if you have understood about agents, then you will actually understand this also. Okay. Now the point here is that I have given you the overall picture right now. So review the, not just the video also, but review the entire Colab notebook, try to work with it and start working on these memories also and see how it works and what are the review the if you are having time, review the documentation, Langchain documentation, and implement the summary memory and summary buffer memory and see how is the difference. In case of summary memory and summary buffer memory, you will need an LLM. In case of knowledge graph memory also, you will need an LLM. Till buffer memory alone, you don't need an LLM. Anything that is involved with summarization, knowledge graph, or entity creation, you will need a LLM to be associated with it. And all these memories can be included in the chains and agents. So you can, so you see how is the complexity increasing. Once you understand the basics, then you can start working with the basic methods, and then you can start implementing that inside the agents and chains, and then you can implement these agents and chains in your products. So the complexity starts skyrocketing rapidly. So keep this in mind, that once you understand the basics, then you can understand a lot of more difficult implementation inside the large language models. If you miss the basics, then it is going to be extremely difficult for you to read the code and predict what is going on inside the code. The idea of sharing all this is that you can master not just large language models and automating it. You have to also master reading others' code. So someone actually comes and shares you their code. You have to read it, right? And also understand, okay, what is going on in their code. How are you going to do that? Unless you go back and go to the browser, go back and execute all these things and see what is going on, it's not going to be possible for you guys to understand these things, because it is beyond our regular programming processes. These are lots of abstractions have gone into this. So just by looking at the code, you will not know what is conversation chain going to do. You will not know what is conversation entity going to do. You cannot understand that. You have to either read the documentation, or you have to probably look at the code, which is, I mean, it is a lot of time, right? You have to spend a lot of time in reviewing the code. It is always better that just initiate the object and see what it does. And that will actually give you a lot of information that even the documentation or the code will never give you. At least for me, it has worked really well, and I would really suggest that try this out, and I hope that you will enjoy working with memory modules in Langchain. With this, guys, I would like to come to a close of this particular video. As I always say, take the look at the Colab notebook and start practicing. Do leave a like in the video if you like it, and share it with others. Subscribe to my channel so that further Langchain related, big data related concepts will be shared with you guys right to your YouTube dashboard itself. So with this, as usual, with 4 words: practice, 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 practice. See you guys till next video. Have a great time.